Hello, welcome everyone. I am Surendra Sir, Master Teacher of Mathematics in Vedantu. In my sessions, which I started last week, in which I talked about Newton's identities and recurrence, today I will be talking about linear equations in three variables. Okay. First, I will take the case of non-homogeneous case. This session is all about finding the shortcut method to solve this kind of equations. Okay. For that, I will talk about the existing cases. Okay, I think we know the existing methods are, first one is Cramer's rule. In this Cramer's rule, you first find the values of d, dx, dy, and dz. Okay, and using these dx, dy, dz, and d, okay, you find unique solution, infinite solution, no solution. I will not teach you Cramer's rule or the second method. I will stick to my method, that is the shortcut method. Okay, but let me just give you the brief that in the Cramer's rule, if d is not equal to 0, here d was not written actually, I am writing it. D is just a1, b1, c1, a2, b2, c2, a3, b3, c3. If this d is not equal to 0, then we get a unique solution that is given by dx upon d, dy upon d, dz upon d. Okay, and dx, dy, dz are created by d only, where you just replace the first column, second column, third column by the constant d1, d2, d3. Okay, so I think these things are known to everyone. So I will not talk about this, but you can see here I need to solve four determinants to get the values of x, y, and z. So that's a long method. In fact, d is equal to 0, then you will check for dx, dy, dz once again. If they are not equal to 0, then no solution. If they are equal to 0 with some, some conditions, I have written it here, you can go through it. Then you get infinite solutions. In fact, when all 4d are 0, okay, then also there is a scenario when all the coefficients a1, a2, a3, b1, b2, b3, c1, c2, c3 are in same ratio, but different from the ratios of d1, d2, d3. Then even if even in that case, all d, dx, dy, dz are 0, but you get no solution. Okay, so here what I'm saying, uh, there has to be some easy method. Okay, method 2 is also similar to that only, where we write those three equations in the form of matrix Ax is equal to b, where A is this matrix formed by coefficients x, b. Okay, then if determinant of A is not equal to 0, then we can find this matrix X in terms of A inverse B. A inverse can be written as adjoint of A upon determinant of A, and like this. Okay, in fact, here also, if you are having determinant of A equal to 0, then adjoint of A into B. If it is not null matrix, then no solution. If it is null matrix, then infinite solution with this condition. Okay, in fact, similar to that Cramer's rule case, if determinant of A is equal to 0, okay, similar to that case, if all a1, a2, a3, b1, b2, b3, c1, c2, c3 are having same ratios, but d1, d2, d3 are not in the same ratio, then also your determinant becomes 0. Adjoint of A becomes a null matrix, so this product becomes null matrix, but you find no solution. Okay, so dear all, these are two methods which we normally use, but these are very lengthy methods. I have not discussed these methods in detail. If you want to know about these methods, go through your textbooks or your lectures, whatever you are having with you. Okay, here I will talk about this method, that is shortcut method. Okay, that is shortcut method, short trick. Okay, what I have written here is actually to find unique solutions, or there will be no solutions or infinite solutions. We need four determinants or adjoint of A, which requires 9 cofactors of elements of A. So it looks like a lots of calculation. So my shortcut method, let us come to the shortcut method. Now to understand this shortcut method, we have to understand that these three equations in x, y, z can be understood to be equations of planes in 3D topic. Planes means like a wall, like a this floor, ceiling, something like this. Okay, now when we are solving them, we are trying to find points x comma y comma z which are satisfying all the planes simultaneously. Now there can be scenarios when there is no point that can satisfy all the three planes, or there can be infinitely many points, or there can be just one point. Okay, so based on that, you will be getting unique solutions, infinite solutions, or no solution case. Okay, let me just tell you that if your planes are something like this, one plane is like this, okay, and there is another plane which is intersecting this plane, something like this. Okay, this is my another plane. So this is the line of intersection. Okay, so for any two planes, you can see if they are not parallel, they will always have a line of intersection which is having infinitely many points. Now, if for first two, if I have to talk about, they will have infinite solutions if they are not parallel, okay, in the form of a intersection line. Now this P3, how is P3 located with respect to this line of intersection will decide whether you will have just one solution. It is possible if your plane is something like this, where it is intersecting this line at just one point, so there will be just one solution. Okay, or maybe it is possible that your P3 is having this line lying in the plane, then you will be having infinite solutions, because the entire line is lying not only in P1, P2, but it is also in P3. In fact, it's a line of intersection of pairwise P1, P2, P1, P3, and P2, P3. Okay, there can be a scenario where there is a plane. Let me call this plane with this color. Okay, so that plane is it's parallel to this line, but it is away from this line. This plane is there, which is away from this line, but it is parallel to this line. So in that case, this line of intersection and this plane will never have any point common between them. So in that case, there will be no solution. So total, there are three cases. Okay, there are a few more cases which I will talk about later, when these planes themselves become parallel or identical. That I will keep separately. Otherwise, this discussion will become a bit complicated. Okay, so here we will talk about the short trick when there are no two planes, when no two planes are parallel. I will talk about that case first, when no two planes are parallel. And when no two planes are parallel, as I talked about earlier, the two planes will be intersecting on a line that is, in this diagram, I have taken planes, cross section diagram of the plane. Planes are going into the plane of this screen. So this point is also actually a line that is going into the plane of the screen. Okay. Now your third plane, suppose this is plane P1, this is plane P2. Okay. Then third plane can have many situations. One of situation can be that it is containing this line, and it is also perpendicular to this plane of screen. In that case, you will be having infinite solutions. If your plane is slightly shifted but parallel to this position, in that case you can see this line will never meet this plane at any point, so no solution. Okay, but your plane is something like this, not in this diagram. It is something like that, where it is intersecting this line of intersection at one point, then you may have unique solution. So I will explain this shortcut method when no two planes are parallel, starting with infinite solutions. There is a reason for this, I will tell you. I told you that infinite solution case is when all the three planes are like this. Means they are having a line, common line of intersection. In three dimension, we have seen this kind of situation is talked about as family of planes. We find equation of a plane that is passing through the line of intersection of two given planes. So here you can see the third plane, or any one of the plane, is member of family of planes uh, that that are having common line of intersection, maybe line of intersection of plane P1 and P2. Okay, so here I will use family of plane concept to find these solutions. Please see how. So what I said, if infinite solutions are there, then you will require that P3 can be written as some constant P times your plane P1 plus Q times plane P2. Okay, some value Q, some value P multiplied with here, some value Q multiplied here will be able to give you P3. Now, if you compare the coefficient, you can see you will be getting A1 into P plus A2 into Q, and that will be equal to A3. That is my first equation. Okay. Now, similarly, B1P plus B2Q should be equal to B3. Likewise, C1P plus C2Q will be equal to C3, third equation. And on the right hand side also, D1 into P plus D2 into Q should be equal to D3. That is fourth equation. Now you can see for those planes, for those equations where A1, B1, C1 all are known, I think only unknown numbers values are P and Q. And I think only two equations are sufficient to solve to get values of P and Q. Okay, if you are getting those values of P and Q, okay, I think you can check whether those values of P and Q are satisfying 3 and 4 also or not. Now, in this case of infinite solutions, okay, what I am saying, the method is P and Q from any two equations. It can be 1 with 3 also, from 1 and 2, okay, and use only first three, not the fourth one. Fourth one is only for verification purpose. So PQ from 1 2 or 1 3 or 2 3, okay, if satisfies 3 and 4, 3 as well as 4, okay, then you will have infinite solution. You will have infinite solution. Okay, that's it. That's it. That's it. To find whether infinite solutions are not there, you have to make these four equations, and these four equations will be used to find no solution and unique solution case also. But for infinite solutions, you need to have PQ obtained from 1 to satisfy 3 and 4 also. Okay. Now coming to the next case, that is no solution. In this case, your planes are like this, where prism is formed. This is the line of intersection of first two planes, and your third plane is parallel to this line but away from it, so there will be a prism formed here. So in this case, please understand, in this case, P and Q obtained from first two equations. In my previous slide, you can go back, 1 and 2, I'm talking about this 1 and 2. Okay, if you are getting P and Q from first two, satisfies 3 but not 4, then you will be having no solution. That's it. No solution. I'm talking about when no two planes are parallel. When planes are parallel, I'll talk about that separately. Okay. Now for unique solution, once again, P comma Q from 1 and 2 does not satisfy equation 3, then you get unique solution. That's it. Okay, I think you have understood. When planes are not parallel, then what is to be done? Let us try to see this in one example here. Okay, now we are given three planes, P1, P2, P3. Okay, and we have to find unique solution, infinite solution, no solution. Okay, so how we have to do? We will multiply P1 by P, small p, P2 by small q, and it should give me P3. So my first equation will become P plus 2q is equal to, I think, 1 here. For y, it will be minus P minus q is equal to minus 2. Now you solve it, you just add them, you will get the value of q as minus 1. And if you put it here, P value will be 3. Yeah, it will be 3. Now you have to check whether this is working on Z or not. Now Z, if you see, it is 3. Coefficient of Z is 3. So 3 into 3, 9. And plus 1 into minus 1, so minus 1. It should be equal to alpha for the case if you want no solution or infinite solution. But if they are not equal, as I told you, if they are not equal, then you will get unique solution. So you have got one answer. You can see this unique solution thing, we have done it. Otherwise, you will do it by making a determinant D. But I think one determinant will be required, but still that will be bigger calculation. This you can see. Okay. Now, if 9 minus 1 is equal to alpha, that is the case when unique solution will be there. If alpha is equal to 8, okay, then we have to check whether there are infinite solutions or no solutions. So for that, I will check for the constant term. So P multiplied with this 2, that will be 6. This 4 multiplied with this minus 1, so minus 4. And here it should be 3. It looks like not true. It is not true. If it is not true, that means same values of P and Q as I discussed here obtained from 1 and 2 satisfies 3, but it doesn't satisfy 4. That means no solution. So in this case, if alpha is equal to 8, you will be getting no solution for alpha is equal to 8. So answer for this is B and D. Okay, I think this one is, if it is not satisfied, your this diagram will be like this where prism is being formed. Okay. Okay, I will tell you that if we can find after this the unique solutions also. Suppose your case is of, this your case is corresponding to unique solutions where alpha is not equal to 8. I will take only this space, please understand. I will tell you how you can find the solutions also if alpha is not equal to 8. Please see. If alpha is not equal to 8, I will use same P and Q. Okay, I will multiply this P1 by 3, Q by P2, that this P2 by -1, and subtract from P3. So as we started with there only, where we started with P3 is equal to P1 into P plus P2 into Q. So if you multiply P with P1, Q with P2 and subtract P3, your coefficient of X and Y will become 0. Okay, only coefficient of Z will remain. And that too will be, you can see this 3 multiplied with 3, so 9, and 9 minus 1, 8, and minus alpha. So it will be 8 minus alpha. What I have done, let me write it here. I have multiplied P1 with 3, P2 with -1, okay, and minus P3. Okay, so this is giving me 8 minus alpha into Z. And on the right hand side, you can check it will be, I think, -1, because 3 into 2, 6, 6 minus 4, 2, 2 minus 3, so -1. So you can see we have obtained the value of Z by doing this thing. Okay, no need to find 4 determinants. Z is there. Now, if you know Z, suppose alpha was, let us say, 2, then you will get some value of Z. Now put that value of Z here, and only 2 equations, first 2 or any 2, you will be able to get the values of X and Y also. So this is how this shortcut method works for no solution, infinite solution, or unique solution case when your planes are not parallel. Okay. We can do one more question here. Here they are asking 3 planes are this. Okay, they form a triangular prism if. Now please understand here what we can do, because triangular prism means no solution case. Okay, now you know no solution case or infinite solution case, in both of them we equate determinant equal to 0, D equal to 0. Okay, so here I will suggest, I am not saying that shortcut method will not work. I will suggest you start with D equal to 0 only, where first row will be 1 minus 1, 1, then lambda 3, 2, and here it will be 3, lambda and 1. Okay, now if you open it, maybe we can use a property where first column is as it is. Okay, and this is added to second column, so 0 here, 3 plus lambda here, and lambda plus 3 here. Subtract the third column from first one, so 0 here, 2 minus lambda here, and -2 here. Okay, now if you open in the first row, you will be getting, I think, 3 plus lambda into -2 minus lambda plus 3 into 2 minus lambda. Okay, if you equate this to 0, I think we get 3 plus lambda common, and -2. So I think it is lambda minus 4 equal to 0. So there are 2 values of lambda we are getting, that is 4 or -3. Okay, now you have got these values. Now whether it will be triangular prism or not, I think you can use that short trick, because we will multiply P with this, Q with this, equal to this. That method, I think you can do it, and you will be able to see whether for both of them it is triangular prism or for one of them it is triangular prism. So that method you can do. Okay, we can use shortcut method for this kind of questions also to find lambda, but it may be confusing for some of them. Let me try to do this question with that method also. Please see, suppose you have to find the values of lambda with that shortcut method. Please see. Okay. So first case, first thing that you will be multiplying this with P. You will multiply second with Q, so plus lambda Q, and that will be equal to here 3. In this case, minus P plus 3Q, and that will be equal to lambda here. And for Z, P and plus 3Q, sorry, for Z, I think we are talking about, not 3, it will be 2 here. And on the right hand side, it will be 1 here. Okay. Now, I have taken 3 equations because all 3 has to be satisfied by PQ. Fourth one should not be satisfied if it is a triangular prism. Okay. Now, 3 unknowns are there, so I think 3 equations are required. Okay. So, what we can do to solve this, we can maybe solve A and C. If I solve A and C, if you subtract first with third, so you will be getting lambda minus 2 into Q is equal to 2. You subtract first from third, so that is what we will be getting. If you add second with third, so I think we will be getting 3 plus 2, 5. We will be getting 3 plus 2, 5 into Q is equal to lambda plus 1. So from here, if you eliminate Q, you will be able to get the values of lambda. I will not do it because I know they will be getting same answer. We will be getting same answer. That is lambda is equal to 4 or minus 3. You can directly put the values and you can check. For 4, it will be 2 upon 5 and 2 upon 5. For minus 3, it will be minus 1 here and minus 1 here. So these values are satisfied here. Now you can see for lambda equal to 4 and minus 3, what are the values of P and Q, and check whether right hand side is satisfying or not satisfying. Okay. So you will be able to find out whether triangular prism is being formed or not formed. Okay. So I'll move to the next thing now. I'll talk about when planes are parallel. I talked about when planes were not parallel. Now please see, if planes are parallel, there can be infinite solutions. Okay, let me show you in this diagram itself, infinite solution in this slide itself. If infinite solutions are there when planes are parallel, there can be 2 scenarios. Please see. The first scenario is that all the 3 planes are identical. All the 3 planes are identical like this. 1, 2, and 1, 2, and 3. All the 3 planes are identical. So every point is lying on all 3 of them. I think it's a very trivial case. All the 3 equations will be same. Maybe like AX plus BY plus CZ is equal to D. Same. AX plus BY plus CZ is equal to D. AX plus BY plus CZ is equal to D. Okay. So if you can observe that this kind of equations are given, or in questions where some unknown is to be found, and after knowing that unknown, you are getting this kind of equations, you can directly say infinite solutions are there. Okay. There can be one more situation. There can be one more situation when 2 planes are identical. Okay. And third plane is something like this. In this case also, there will be a line of intersections of first 2 planes with the third plane. In fact, the first 2 planes are not 2, rather they are 1. So 2 planes intersecting in an infinite line, so there has to be infinite solution. Okay. In such cases, I will suggest, if some unknown is to be found for infinite solutions, as we did for the previous question, try to find D equal to 0. That will give you those unknowns, and then you start with your shortcut method. That will be better. Okay. Otherwise, you may confuse somewhere and you may find that something wrong we are doing. So this will definitely work, but first you find D equal to 0 and then start with that shortcut method. Okay. Now, no solution case. No solution case when parallel, when planes are parallel. Sorry, when planes are parallel, it will be if 3 planes are like this, or maybe 2 planes are like this and third plane is like this. In both the scenarios, you will not get any solutions. Here you cannot get, here also you cannot get. One plane with the second one will have infinite line of intersection. Here also infinite line of intersection, but these 2 lines will not meet each other at any of the point. So no solution. Okay. So here what I'm saying, that start with D equal to 0. Okay. And check whether your situation is like this or this, or previous two. So you will be able to conclude whether infinite solutions or no solutions. So I'm asking you to go into the method of planes, not dx, dy, dz or adjoint. Still, I will say you can consider this as a disclaimer from my side. If you are not very convinced with this method, stick to your old method, but try to apply these methods in many questions. Now I will do it. Okay, I will do it in previous questions. Unique solutions when planes are parallel. Sorry, when planes are parallel, unique solution is not possible. Please understand. If planes are parallel, then unique solution is not possible. For unique solution is to be there, all three planes should be non-parallel to each other. So that is not possible. Homogeneous case, when right side you are having 0, 0, 0, shortcut method will work exactly as it is as it was working for when it was d1, d2, d3. You don't need to check for the fourth equation, because p into 0 plus 0 into q will be equal to 0, whatever pq you are getting. So here you can make three equations for a1, a2, a3, b1, b2, b3, c1, c2, c3, and you can check whether infinite solutions are there. Okay, in fact, let me tell you, in this case, no solution is never the scenario, because 0, 0, 0 is always a solution. So if you apply shortcut method also, you will find that you will not get that in no solution wala case. That prism wala case will never ever come. Prism wala case was when that p1 pq obtained from first two equations, that is from coefficient of x and y, is satisfying the coefficient of z but not satisfying the constant terms. So you can see the constant terms are 0, 0, 0. So that fourth equation will definitely be satisfied. So that is not the scenario here. You will always get a solution. So either unique solution or infinite solution. Okay, I think that's a summary. You know it already. In this case, never a case of no solution. If d is not equal to 0, okay, then all x equal to 0, y equal to 0 is the only solution, which is also called as trivial solution. Okay, in fact, that's the condition for trivial solution. If you only trivial solution, there has been many questions based on that. If d is equal to 0, you will get infinite solutions that include this trivial solution also. Okay. Now I will take few questions from previous year. My first question is from 2018. 2018, and that was supposed to be a decent question. It was not easy question that year. So please see what they are giving us. S is a set of all column matrix B1, B2, B3. Maybe you can say S is a set having ordered triplets B1, B2, B3 such that they all are real number, and the system of equation has at least one solution. Then which of the following system has at least one solution for each this B1, B2, B3 belongs to S? Okay. Now we have to first check whether this is a case of infinite solution or unique solution, because we need to have at least one solution. Maybe you can do this thing directly by taking D equal to 0 or not equal to 0. Let me tell you, I have done this question multiple times. Your D comes out to be equal to 0. Okay, but if D is equal to 0, you will have to check when B1, B2, B3, for what relation between B1, B2, B3, you will be having infinite solutions, because we need to have at least one solution. No solution case is not accepted here. And also, all the planes are such that no two of them are parallel to each other. Okay, now I will go with my shortcut method. Please see, and my shortcut method was that we multiply first with P, second by Q, and we obtain the third one. So for X, coefficient of X, it will be minus P plus 2Q is equal to 1 for X, coefficient of X. For Y, if you check, it will be 2P minus 4Q is equal to minus 2. In fact, these two are same equations. You can check. We have multiplied this by minus 2 only. For third one, this is 5P plus 3Q, and that is equal to 2. If we solve first with third or second with third, anyone, what I need to do, I need to multiply this by 5 and we add with this. So we will be getting 5 into 2, 10 plus 3, 13Q, and that will be equal to 5 plus 2, 7. So your Q is coming out to be 7 upon 13. And if we put it here, the value of P will be 7 into 2, 14. So 1 upon 13. Let me check. 14 minus 1, 13 upon 13, that is right. And here 5 plus 21, 26 by 2, so that's right. Okay, so these are the values of P and Q, and already these X, Y, Z are satisfied. In fact, the equation we obtained from Y was same as we were obtaining from the X. So I think for infinite solution case, I think that's a scenario when all three are satisfied. But for infinite solution, you need to have same relation between B1, B2, B3 also, which means my B1 multiplied with 1 upon 13 plus B2 multiplied with 7 upon 13 should be equal to B3. Or you can say B1 plus 7 B2 will be equal to 13 B3. Okay, so what we have obtained here, that if your B1, B2, B3 are satisfying this relation, then this will have at least one solution, rather infinite solutions. So this set S will be having only those B1, B2, B3 which are satisfying this relation. Okay, this thing can be obtained by dx equal to 0 or dy equal to 0 or dz equal to 0 also. Okay, in fact, when you are taking infinite solutions, ideally you should check for all dx dy dz being equal to 0. So here we are doing just by making one simple equation. Okay, now let us see how other options will be checked whether they are correct or not. What is the question then? Please see, which of the following systems in real variables has at least one solution for each b1, b2, b3 belonging to this S. Now first let me write the relation between b1, b2, b3, 1, 7 and 13. So we obtained my b1 plus 7 b2 should be equal to 13 b3. Okay, that is the relation if we want these b1, b2, b3 to be there in this S. Okay, now for A option, I will use my shortcut method. Okay, now you can see here P X term is not there, so plus 0 into Q, and that should be equal to 1. So your value of P is coming out to be 1. Now for Y, if you apply, it is 2 into P plus 4 into Q, and that will be equal to 2 here. Because P is already, we have found 1, so 2 will go that side, so Q is equal to 0. Okay, now let us see whether this is satisfying the Z also or not. So P into 3, that is 3, and 0 into 5, so 0 should be equal to 3, but it is given here 6. You can see 1 into 3 plus 0 is equal to 6 is not 2. That means that's a case of unique solution. That's a case of unique solution. And you can verify this thing by taking the determinant, that the determinant of these coefficients of x, y, z will be not equal to 0. So whatever b1, b2, b3, that means for every b1, b2, b3, this will have just one solution. So for this relation also, these plane will give you one solution. So A should be one of the answer. Okay. Now coming to the B option. Here you can see this is I think they are having X. All the terms are there. So for this P is different from A option. Please don't confuse with this. P plus 5Q is equal to minus 2, and this is P plus 2Q is equal to minus 1. All these two subtract, I think you will get Q is equal to, I think, minus 1 upon 3. And if you put it here, the value of P comes out to be, I think this is minus 2 upon 3. I think this is also minus 1 upon 3. They both are coming out to be minus 1 upon 3, minus 1 upon 3. Now let us check whether this is satisfying the Z thing or not. So if you multiply this by minus 1 upon 3, so minus 1, minus 2, minus 3. So that means this second case, second option is having the planes which will be either forming a prism, or they will be meeting at common line of intersection. Okay, now we want at least one solution. So this is not accepted. We want common line of intersection, and that will happen if these PQ are giving you relation in B1, B2, B3 also. That means minus B1 upon 3 minus B2 upon 3 is equal to B3. Now you can see this relation is not same as this relation. Maybe the solution of these two can give you certain value of B1, B2, B3, but every value of B1, B2, B3 that satisfies this will not satisfy this. That means in that case, this system of linear equation in option number B will not give you any solution. So this is not the answer. Please understand. They are saying for each B1, B2, B3 belongs to S. Maybe some values which are satisfying both of them. Maybe linear equation can be solved to get B1, B2, B3, but not every value of B1, B2, B3 here will satisfy this. Hence, this option is wrong. Now, coming to C option, minus P plus 2Q will be equal to 1 here, and this 2P and minus 4Q, 2P minus 4Q is equal to minus 2. If you solve it, I think they are same equation. They are same equation. Okay. In fact, yeah, there is one thing very important. Please listen carefully. Actually, if you do it for third equation, please see, you will be getting minus 5P, okay, plus 10Q is equal to 5. Now you can realize all the three equations are same. They are same because the coefficients of X, coefficient of Y and Z are in same ratio, which is because they all are, parallel planes. They are parallel planes. They can give you solutions only if they are all the three are same. All the three are same planes. And you can see from this to this, if I have to create this plane 2 from this, it is multiplied by minus 2. This is minus 2 times of this. And this is minus 1 times of this. So here solution can be there. Actually, all are parallel planes. So solution can be only there if B1 divided by 1 is equal to B2 divided by minus 2 is equal to B3 divided by minus 1. Okay, so that should be the relation between B1, B2, B3 if you want solution from here. But once again, this kind of relation may not be necessary for this relation to be true. Okay, hence, once again, this will not give you solution. They will be, parallel planes at a different distances, different heights, you can say. So there will be no solution. Okay, this D option I will, now leave because this is same as the A option. Okay, you can check that you will be getting, unique solution in this case also. So you will find some PQ, but that PQ will not satisfy for Z. So there will be unique solution for D. So answer D is also there because we want at least one solution. So this question of JEE Advanced 2018 is solved, is solved. I hope you understand it, that how we have done it. We started with, previous slide. For this system of linear equations, we found PQ. We obtained relation between B1, B2 by that shortcut method only. And then we checked that all the options, because we have to solve each and every, we don't know which system they have given. So we have to solve for each option. So we solved for each option and we found first and last are corresponding to unique solution. And I have not done that D not equal to 0 thing. You may do it. Okay, I have done it by my shortcut method. And B and C, by shortcut method only, we concluded that they will not give you solution. I think this one is giving you, I think, prism case, and this is giving you three parallel planes. So no solution in these two cases. Coming to one more question of 2021. I think this was also very interesting question. Please see. Alpha, beta, gamma are real numbers such that this system of linear equation is consistent. Consistent means at least one solution. Okay. Here again in X, Y, Z, there are no unknowns. I think my method will perfectly work here. So take P plus 4Q is equal to 7. 2P plus 5Q is equal to 8. Solve them. Okay, I think 2, if you multiply here, so 8 minus 5, 3Q will be equal to 6. So the value of Q coming out to be 2. And if you put Q here, okay, so 8, I think it will be minus 1. Let me check. Minus 1 plus 8 is 7. And minus 2 plus 10 is 8, correct. Now, whether it is satisfying the third one, let us see. So minus 1 into 3, so minus 3, 2 into 6, that is 12. And that will be equal to 9. That is true. That is true. So that means it will have either infinite solutions or it will have no solutions. Case of unique solution is rejected. Now, this is consistent means it should have infinite solution, and that will be possible if These same PQ satisfies the right hand side also, which means this -1 multiplied with this alpha and this 2 multiplied with beta, and that should be equal to gamma minus 1. Okay, so here we will be getting the relation between alpha, beta, gamma as, if I take this on the other side, alpha minus 2 beta plus gamma minus 1 is equal to 0. Okay, now please read this question once again. They are saying this denotes the determinant of the matrix. So we have to find the value of this determinant. And also P is a plane containing all those alpha, beta, gamma. So you can see this is a plane X minus 2y plus Z equal to 1 or minus 1 is equal to 0. Okay. P is the plane containing all alpha, beta, gamma for which above system of linear equation is consistent. And D is the square of distance of the point 0, 1, 0 from that plane P. Okay. So let us first find this M. I think for this M, you can observe certain thing that going with this relation, alpha minus 2 beta plus gamma. Maybe I will use a property. Which property I will be using? Please see. Column 1 I will change by column 1 minus beta times C2 and plus C3. So this alpha minus 2 beta plus gamma, which is equal to 1. So first term will be 1. And you can see these two will become 0, 0. Because beta minus beta 0, and this is 0 only, minus 1 and plus 1, 0. So 2, 1, 0, gamma 0, 1. You can solve it, you get the answer as 1. Okay, so this is the answer of this question number 7. Answer is 1. Let us try to find the value of D. D is nothing but the square of distance of point 0, 1, 0 from this plane. So we have a formula directly, 0, 1, 0. The plane was alpha minus 2 beta, alpha minus 2 beta, and it was plus gamma. So this minus 1 is equal to 0. If you want to write an equation, it is better to write in terms of x, y, z. Although in objective question doesn't matter. So putting 0, 1, 0 will give you minus 2 minus 1 upon root 6. So that is the distance, and we want D, which is actually square of this thing. So 9 upon 6, that is 1.5. So I think this question is done. I think that part of 3 linear equation was just that much, that what is the relation between alpha, beta and gamma. Now you may do it by dx dy dz method or adjoint method, your choice. But I'm 100% convinced that this short method is definitely better for these questions. One more question. I think I'm having one more question after that, and then this session will end. Now question number 22. PQR are non-zero real numbers that are 10th, 100th and 1000th term of HP. Consider the system of linear equations. Okay. Now please see the third equation. If I divide by PQR, will become x upon P plus y upon Q plus z upon R equal to 0. And because PQR are in AP, sorry, HP, 1 upon P, 1 upon Q, 1 upon R will be in AP. I can write them as capital PX plus capital QY plus capital RZ equal to 0, where this P is, 10th term. So I can write it as A plus 9D. Q is equal to A plus 99D, and R is equal to A plus 999D. So these are the relation of PQR, which are the 10th, 100th and 1000th term. Okay. Now we can check whether unique solution, infinite solutions. Okay. Consider the system of linear equation. We have to find for what values of Q and Q upon R, P upon R, they will be having infinite solution, no solution, etc. Okay. Now for no solution, infinite solution, you can first make that D. Okay, your choice. Let me try my shortcut method only. So what I'll do, I'll be taking P dash because P was already there. So P dash plus 10 Q dash will be equal to P here, and P is what? A plus 9D. Okay. Similarly, P plus P dash plus 100 Q dash will be equal to A plus 99D. If you solve them, okay, if you subtract them, you will be getting Q dash is equal to D and P dash will be equal to A minus D. Okay, and you can check this is going to satisfy Z also. For Z, what I need to have? I need to have P dash plus 1000 Q dash is equal to A plus 999D. You can check this is getting satisfied. So that means this cannot be a case of unique solution. I think we should forget about that thing, that you cannot have unique solution. So here also they are not saying unique solution. They are saying either infinite solution or no solution. At least one solution can also be considered in infinitely many solutions. Okay, and these are as a solution. They are saying they are not claiming they are unique solution. Okay, so unique solution case is gone. You can only have either no solution or infinitely many solutions. Okay, let us see what Q upon R is equal to 10, P upon Q equal to 10 means. Okay, let me go to the next slide. Q upon R. Q upon R means it will be capital R upon capital Q. Okay, that means capital R was the PQR 1000 term. A plus 999D upon Q is the 100 term. So 99D. If it is equal to 10, Q upon R it is 10. If you cross multiply, you can check, you will be getting A is equal to D. You will be getting A equal to D. Okay. Similarly, if you take P upon R, if you take P upon R, actually, yeah, P upon R also, if you take P upon Q, sorry, P upon Q, P upon Q, if it is taken as 10, then also you will be getting A is equal to D. Okay, I think they have given only two things, Q upon R, P upon Q. Okay, and this is same P upon Q. So P upon Q, if it is not 10, you can check P upon Q. If it is not 10, then A will not be equal to D. Let me write all the conditions arising from this. I will not do the calculation, but you can check that P upon R not equal to 100 also gives you the same thing, that A is not equal to D. Okay, so corresponding to these four things, if this is equal to 10, then your A becomes equal to D. Here also A equal to D. Here A is not equal to D. Here also A not equal to D. Let us go back to the previous slide. Okay, now please see, if A is equal to D, that is the case of first option and the last fourth one. So if A is equal to D, then P dash will become equal to 0. Okay, if P dash is equal to 0, you can see this relation will be true for right hand side coefficients, constant actually. 1 into 0 plus 0 is equal to 0. That means if A is equal to D, you will be getting infinitely many solutions. That means for first one and the last one, you will be having infinitely many solutions. So one of the options true for them should be R. Okay, in fact, no solution case cannot be there for first and fourth. If in first and fourth they are saying somewhere S, they should be straightforward rejected. Okay, that is for this thing. Now, if P upon R is not equal to 100, then A is not equal to D, A is not equal to D. In this case, P dash will not be 0. Now, if you multiply P dash with this 1 and whatever value of Q dash with 0, I think on the right hand side, constant term will not satisfy this equation, which means they will give you no solution case. So it will be S here, S here. So I think this is coming out to be in the B option. You can see in first option, second is matched with R. R means infinite solution. So this option is wrong. In second, third, there SS. Let me check for C also. Second one is matched with R. So this is also wrong. Third one, last one. Second is S, third is P. Third is P means this is as a solution. I think this is also not true because no solution means no solution can be there. This can also not be the solution. So only B option is there. Also, you can check one is giving you as Q, one is giving you as Q. Q means this as a solution. I think we can check for one, we are getting infinitely many solutions. And one of them is this by putting these values here. Z is equal to 0, Y is equal to minus 1 by n, etc. Okay. And what is the other thing? Fourth is R. Yeah, fourth is R only. They have given as the infinitely many solutions. So answer for this is D. So you can see this question is done with the help of that shortcut method. Last question, 2023. I think one more question after that. Alpha, beta, gamma are real numbers. Consider the following system. Match each entry to the correct Again, you have to find for which relation of beta with alpha, unique, no, infinitely many solutions, and as the solution. So once again, I'll do the same thing. Multiply this by P, this by Q, and equate. So you will get P plus Q is equal to 2. You will get 2P, and there is no, y term here, so 0 is equal to minus 3. So we will be getting P as minus 3 by 2, and we put it here, we will be getting Q is equal to, we will be getting Q is equal to 7 by 2. Okay, and this should be this should be valid for Z if you want infinite or no solution. So it will be how much? P multiplied with this 1, so minus 3 by 2 plus alpha into 7 by 2 is equal to beta. If this relation is true, then there will be either infinite or no solution. Okay, if it is not equal to this thing, there will be no solution. Please understand, if this is a scenario, then there will be no solution. So you can check for R and S. Just 1 minute. For R and S, sorry, this was the scenario for unique solution. That was the scenario for unique solution. So R and S should have unique solution, that is 1 and 1. Okay. Also, with unique solution, you may find the solution as well. Okay, that we can find separately. But for beta is equal to this thing, when minus 3 by 2 plus 7 alpha by 2 is equal to beta, and right hand side also we have to check. So P multiplied with 7, so minus 21 by 2 plus 11 multiplied with this 7, so 77 by 2 is equal to gamma, gives you gamma is equal to 28. If both are true, then there will be infinitely many solutions. So you can see, if gamma is equal to 28, beta is equal to this thing, then you should have infinitely many solutions, that is 3. If beta is equal to this thing but gamma is not equal to 28, then we will be having no solution, that is 2. Okay, let us see if we can find out answer with the help of this thing. So already they have given P as 3 or 2. Okay, so if P is 3, I think P cannot be 2, so last two options are wrong. P is having infinite solution, so no solution option is ruled out. Only first two options are there, and Q is already 2. Okay, that is right. For R, it is 1, that is the unique solution. Here it is R5 also. Maybe that can be a solution with unique solution. So let us wait for S now. For S, it has to be 1. 1 means unique solution, but they are giving 4, 4 in both of them. That means, because one of these option has to be true, so this S has to have this as a solution. Okay, so this is the only differentiating factor. I think R matched with 1 cannot be wrong. Please understand, it is having unique solution. So in my opinion, this will be the answer. We can check whether R can be matched with 5 also or not. We see if if gamma is not equal to 28, okay, and they are saying Z equal to 0, X is equal to this thing as a solution. Let us see what we will be getting here. X is equal to minus 15, so minus 15 plus 8 is equal to 7. I think this is matched. 5 minutes. Okay. This is matched, and if you put which one? 5. 1 minute. Minus 5. Yeah, I think we are talking about this thing. If you put it in this one, it will be minus 15 is equal to 11. I think this is not a solution. This is not a solution. So I think option A is correct of this question. Okay. So, bacho, last question. Okay. Actually, this question I kept in the last. It is a question from 2017. Okay. This is question just asking infinitely many solutions. You may use shortcut method, but I will suggest in this kind of questions where this if you take PQ and there will be 3 equations there involving alpha beta into it, it may become bit confusing. Although I have done it and it can be done by shortcut method, but I will still suggest you that for infinitely many solutions, you go with the old method, this alpha 1 alpha square alpha 1, okay, equal to 0. If you open it, I think you will be getting 1 minus alpha square whole square is equal to 0. Okay, I remember the calculation, that's why I have done it directly. Your value of alpha will be 1 or minus 1. Only 2 values you will get. And now you can see, Okay. Now, after that, I will not suggest that you do that dx, dy, dz. Rather, I will ask you to see if alpha is 1. My all the coefficients will be 1, 1, 1, 1, 1, 1, 1, 1, 1. So, equations of planes will be x plus y plus z is equal to 1, first one. For second one, it will be minus 1. Same thing, x plus y plus z is equal to minus 1. So, you can see these are two parallel planes. So, they cannot have any solutions. Okay. But if you take z is equal to minus 1, this was for 1. If you take alpha equal to minus 1, sorry, alpha is equal to minus 1, then your planes would be 1 into x minus y plus z is equal to 1, first one. Second one would be minus x plus y plus, sorry, minus z actually, minus z, and that is equal to minus 1. You can see these two are same thing, only minus 1 is multiplied here. And for third one, if you put alpha is equal to minus 1, it will be x minus y plus z is equal to 1. So all the three are same planes, hence it is having infinitely many solutions. So for alpha is equal to minus 1, your answer should be equal to 1. Okay, so this is the end of my session today. I hope you have understood it. If you're not finding it, intuitive, you may leave it. It is all your choice. But I will still say that you try to go through this, video at least 2 times. If you're not getting, it will be useful for JEE Advanced and JEE Mains questions also. Try to apply this method in as many questions as you can. Only one thing I will say: whenever you feel that there are too many unknowns are there with x, y, z, or making equations with p and q is becoming increasingly difficult, then you first find the d equal to 0, and then from there you go with this shortcut method. Or if you can directly see what kind of planes are being formed, I think there is no need even for that also. Like in this question, you can see parallel planes. If we can see, then you can directly say there is no solution. Or if all three planes are identical, you can say they will be having infinitely many solutions. So that is all for today. Thank you so much. I'll come with some new thing in the next week. Bye.